Hi guys, welcome back to my channel. In this video, I'm going to explain about the second basic architecture in the computer architecture, that is hardware architecture. Before going into this explanation of hardware architecture, we have to see this digital computers block diagram. In this digital computers block diagram, we have to understand that the input will be given through the input devices and to the input output processor, and this input output processor will send the information to the CPU, and CPU will retrieve through the registers from the random access memory, and the random access memory will give the result what we have asked for, and that will be sent to the CPU, and the CPU will be sent to the input output processor, and the input output processor will send it to the output devices such as monitor, and the architecture that is been here inside the computer is that there is RAM and the CPU. So the architecture is nothing but the things what we are happening in the RAM and the CPU will be discussed. As we have seen in the Vernam architecture, the same thing, and this will be in the hardware architecture, and the only difference is there is only single shared memory in the one human architecture, and next the hardware architecture has the two shared memory, that is data memory and the instruction memory. Let's see what happens in the hardware architecture. First, the see here, in the digital computer, the input will be given to the input output processor, and that will be sent to the CPU. So the input sent to the CPU, and the CPU has some following parts in it: the DPU, arithmetic logic units consists in the DPU, and PCU. DPU is data processing unit. Data processing unit will process the data the user has asked, the user given through the input devices. The data will be processed, and the bulk of data will be processed by the data processing unit, and remaining arithmetic logic of a unit will perform some minor operations in the instructions what the user have given through the input device, and that arithmetic logic unit sends it to, sorry, here I have drawn this wrong, sorry, wait a minute. The arithmetic logic unit actually sends the status information, that is what the arithmetic logic unit has done will be given to the program control unit, and program control unit in name itself it is there that it controls the program, that is it process the uh, information what we have asked, and that will be controlled and sent back to the arithmetic logic unit, and that part the way is called as control, that is control way. And controlling is nothing but restricting data at one point, right? The remaining data will be sent in the paths, okay? So that controlled unit, that is PCU, the memory, the arithmetic logic memory, input and output units are stored and processed operations and performs input output operations in the PCU, so that the status which has sent to the PCU, and that will be controlled and sent to the ALF. And before doing that, the status instructions will be coming to the PCU. Let me take the pencil. The status instructions will be coming to the CPU. That is operations which have done by the arithmetic logic unit. Those are known as status, and that will be sent to the PCU. Those are instructions will be sent to the instruction memory, and that instruction memory also have to be shared to the data memory also, because the instructions what we have in the instruction box and the data memory box will not be linked in the direct form. As in the one human architecture, there is only a single shared memory, so the instruction sent to the memory will be also in the same memory box. But here it is different. If you want to check the difference, you can put the diagrams together and understand the difference, or else I'll explain in the next video the difference between the hardware and von Neumann architecture. Okay, here the instruction will be sent to the data memory, and data memory, that is known as control address bus, okay, which is controlling the address that we are sending to the instruction memory will also send to the data memory, and the instructions which will be performed in the instruction memory should have passed back to the PCU, as it cannot directly give it to the output. So it have to send back to the PCU, and PCU now sends the control unit to the arithmetic logic unit, and the arithmetic logic unit performs the tasks, and that will be sent to the data bus and retrieves the data what we are required. So that from here we can observe that it first operation occurred as instruction memory, and the second thing will happen is data memory. Whereas in von Neumann, it can be at the both sides, like it can start from the PCU or it can start from DPU, no problem with that. But here, as there are two shared memories, so here the instruction memory should occur first and next, so that the control bus will be sent to the data memory, then only the data memory can process the data bus from the DPU. That will be done from PCU, but whatever here the input have to come to DPU, and DPU have to give that to ALU, and ALU has sent to the status. You have to observe that first. This process will be done first, and either the second thing this happens second thing or first thing. This is, suppose, see here what operation here is. Let me write it first. Okay, this is 1. Okay, let me erase this. DPU is 1. Okay, DPU operation is first thing, and PCU is the second one. Now, and this is first A, so let this be A and B. First operation will be done is, wait a minute, let me erase for the easy convenience, understand. Okay. Okay. First, the information have to be given to the DPU. So DPU will occur first, and arithmetic logic operations also will be performed, and that will send to the PCU. So 1 to 2 will be done. And in hardware architecture, the PCU will done first. So 2 to A. And that will send to the data memory. So there will be operation that is A to B. Now the first one will be done. So 1 to B. Sorry, 2 to 1 should be sent first to the control section. 2 to 1. And now 1 to B. And now again B to B to 1 and 1 to output. output. Okay, let's see again. What is actually happening is input will be given to the one, that is DPU. Input will be given to the DPU. One is DPU, and DPU performs some arithmetic logic operations and send the status to PCU, that is 2. And the PCU sends to the instruction memory, that is A. And A, here something is going, that is control address bus, to the data memory, that is B. And that is one way, and the other is instruction bus. So inside this there is some operation going, that is A to 2. Okay, so again here what is happening, this 2 to 1, 2 to 1, that is control block, control thing which is giving back to the ALU. Now 1, that is DPU, sends it to the data memory B, that is B, and B is giving back it to the DPU, so B to 1, and 1 is giving back to the output, that is 1 to P output. That is all the definitions we know. That is DPU is the data processing unit which processes the data, and the arithmetic logic unit performs the minute operations of the data processing that is sent to the ALU, and that will be sent in the status form to the status instructions to the program control unit. Program control unit controls the instructions and sends to the instruction memory, and instructions will be sent back to the control program control, and that control instructions will be sent to the ALU again, and ALU will send to the DPU, and DPU will send it to the address block, and here the control address bus will also be sent to the data bus. Then the operation will be done and given to the output. So that this happens in the hardware architecture. If you want, I'll explain the difference in the next coming videos. If not, you can understand by the diagrams. Okay, thank you.